This is the world's smallest personal AI supercomputer. Revealed by NVIDIA's boss Jensen Huang, it is designed to get AI into the hands of more users through the flagship Blackwell hardware. This silicon beast crams NVIDIA's Grace CPU and Blackwell GPU into a single chip, delivering a jaw-dropping 1 petaflop of FP4 performance. It's built to handle AI models with up to 200 billion parameters, perfect for predicting the downfall of humanity. For those who enjoy living dangerously, connecting 2 units allows you to juggle 405 billion parameters, a setup even HAL 9000 would envy. With Project Digits, the power of a personal AI lab is literally at your fingertips. This compact powerhouse allows you to train, test, and deploy sophisticated AI models directly from your desk. Forget about waiting for cloud resources. With this supercomputer, you can prototype ideas instantly, train custom models for NLP, image recognition, and dive into AI applications that were once beyond your reach due to hardware limits. But this is just the tip of the iceberg. By the end of this video, you'll understand how it actually works, how it compares to traditional systems, and what it means for the future of AI. While Digits or Deep Learning GPU Intelligence Training System is powered by the GB10 Grace Blackwell superchip, the unholy offspring of NVIDIA and MediaTek's year-long bromance. This chip integrates 20 power-efficient cores built with the ARM architecture and NVIDIA's latest CUDA and 5th-generation Tensor cores. With 128 gigabytes of unified memory, the system ensures lightning-fast data exchange between the CPU and GPU, enabling it to process massive datasets with ease. It doesn't just stop there. Digits offers up to 4 terabytes of NVMe storage because AI models massive datasets and your questionable side projects need somewhere to live. All this power operates on a standard wall socket and comes packed in a device smaller than your ex's excuses. If we look into conventional systems, they rely on separate CPUs and GPUs, each with dedicated memory pools, which require frequent data transfers that create latency and limits performance efficiency. In contrast, Digits integrates CPU and GPU on a single chip. This architecture eliminates bottlenecks, enabling the kind of performance conventional systems can only dream of, as if someone invented the wheel all over again but for computing. Where conventional systems often depend on distributed setups in data centers or cloud platforms, Digits tears through AI computations, delivering up to 1 petaflop of FP4 performance. It laughs in the face of data centers, training models with 200 billion parameters from the comfort of your desk. Additionally, Digits allowing users to connect 2 units via NVIDIA ConnectX networking, doubling performance to handle models with up to 405 billion parameters, which is enough to run Llama 3.1. But despite its immense potential, Digits runs exclusively on a Linux-based NVIDIA DGX OS, which aligns with the preferences of most developers but limits its appeal to the average Joe due to the lack of Microsoft Windows support. This strategic positioning defines Digit as a specialized tool rather than a mass-market tool. To unlock its true potential, it needs to infiltrate the Windows ecosystem, but that's easier said than done. Shifting it to Windows is like putting a lion in a zoo with glass walls, beautiful but utterly confined. Linux allows developers extensive control and customization, which is crucial for maximizing the potential of hardware like the Grace Blackwell superchip. In contrast, Windows says play by my rules or not at all. Its closed-source nature restricts low-level optimizations and demands compliance with Microsoft's proprietary frameworks, which can complicate hardware integration. By the time your AI supercomputer is ready, it's more bureaucrat than genius, overwhelmed by red tape and bad ideas. Meanwhile, with his new shield, Jensen took the stage like a knight of Silicon Valley and unveiled the GB200 NVL72 superchip, a silicon monster packing 72 Blackwell GPUs, 1.4 exaflops computing power, and a staggering 130 trillion transistors, delivering performance 30 times faster than the H100. Designed as a rack for data centers and AI-driven workloads, it ensures that industries reliant on massive computational power can operate at unmatched levels of efficiency and speed. Such leaps in performance promise to make AI reasoning models like OpenAI's O3 dirt cheap, so affordable that even your grandma could train her AI pet to outsmart you. And to be clear, the shield was just a glorified toy, meant to make you imagine all 72 GPUs squeezed onto one chip. This is not how it's manufactured or used, at least for now. The primary difference between the GB200 NVL72 and Project Digits lies in their scale. Though both are built on the same Blackwell architecture, GB200 is designed for massive scale operations, making it suitable for large data centers and enterprises working with trillion parameter models and complex AI tasks. Meanwhile, Digits is a compact desktop-scale supercomputer designed to run AI workloads on a much smaller scale. Now, NVIDIA has been one of the largest beneficiaries of the AI boom. Its stock price is nightmares for short sellers and wet dreams for investors. Once a humble GPU maker, now feeds insatiable hunger of tech companies by its advanced AI chips. In a world where AI powerhouses often cater to massive corporations, Digits breaks the mold with a $3,000 starting price, democratizing access to high-performance AI tools to individual users and small teams. Its desktop-friendly design feels almost rebellious in an industry dominated by bulky, inaccessible systems. Beyond reshaping personal computing, Digits fits into NVIDIA's grander strategy. Their recent partnership with Toyota to power autonomous vehicles demonstrates the company's aim to embed AI across industries. As these technologies evolve, the result is a future where AI development is more localized, personalized, and impactful impactful. So what do you think how the future of computing will look like?